Hello everyone, welcome to RMS tutorials. In the previous lecture of microprocessor 8086 16-bit, we have seen silent features of 8086 microprocessor, a pin diagram and also an architecture diagram. Okay, in the today's lecture we will be going to see the architecture of 8086, the remaining block diagrams of it and register organization. Also the concept of pipelining and memory segmentation. Okay, let's go to our PPT slideshow. Yeah, this is the overall architecture of 8086 microprocessor, and the architecture is divided into two parts, which is BIU and EU. As we discussed, BIU is nothing but bus interface unit, okay, which is nothing but transferring the instructions from one segment to the other segment, okay, to the other system also. And EU is nothing but the execution unit, which executes the instruction which is fetched by BIU. Okay, so yes, it is divided into two parts. BIU handles all the transactions, okay, while BIU also performs operations such as fetching, reading, writing operands, calculating addresses and operands. Also, instruction bytes are transferred in instruction queue, and EU is nothing but executing the instructions. First, we will go with execution unit. In the execution unit, it executes the instruction which are fetched by BIU. Also, we also generate control signals which are over here in the register organization. Then it executes the instruction. The main part is nothing but control system over here, instruction decoder, which is also register organization, and ALU, which is arithmetic logic unit, which includes all operations, operands in it. Okay. Yes, then we have general purpose register. Okay, as it is 16-bit microprocessor, it is divided into 88 bytes. Okay, 8 bytes high segments register, and L is nothing but low registers. Okay, low segment register. Then we have AH, BH, CH, DH, AL, BL, CL, DL. Okay, and the total of these 88 bits are nothing but AX, BX, CX and DX. Okay, so what does A represents? A represents the accumulator, B represents the base, C represents the count, D represents the data. Okay, there are two pointers in the general purpose register, which is stack pointer and base pointer. Then we have index. There are two index again, source index and destination index. Okay, so overall these journal registers include for performing a program of microprocessor, which we are going to see. Like, we are not going to see all the programs, but the basic programs which you need to know. Okay, so yes, there we have for that programming run the program on TASM, we need to have these basic registers to get to know. Okay. Then we will go to next. So the pointer and index registers are the journal to keep the addresses offset. Okay, it is used for memory addressing. SP and BP are the default reference for physical address. Okay, as such stack segment in BIU, and index like SI and DI are the basic BX base register, generally default to data segment register. Okay, these things will not get you know now. You will get to know it while we will run the program. We will only run the main programs, but we will cover it over there. Okay, so basically what is stack pointer and base pointer? Stack pointer is nothing but when we used to access stack register, okay, then we use this SS like SP stack pointer, and for the base pointer we need the data segment, okay, which is nothing but the data operands which we are going to use over in segments. Okay, as we discussed what is SI and DI, that are nothing but source index and destination index for the register string operations. Okay, uh, yes, then we have flags and register. Flags over here. Flag is nothing but which indicates some conditions are executed or not executed while they are executing, are in the process, or the instructions are given to them. So how they will indicate us by using flag, which is flip and flop. Okay, in 8086 the EU contains flags which are 16-bit flag register. Okay, 9 of the 16 are active flags and 7 are the undefined flags. 6 flags indicate status flag and 3 flags represent control flags. Okay, over here there are 4 1 2 3 4 flags which are unused. Okay, which are unused. 4 here, 5 6 and 7, there are 7 flags which are unused. 9 of the 16 are active flags. Now what are that 9 flags? Let we discuss. 6 indicates the status. Okay, like status is like as we can see, direction flag. DF is nothing but direction flag, overflow flag, interrupt flag, trap flag, sign flag, zero flag, auxiliary flag, parity flag and carry flag. Whenever the conditions occur, like conditions such as trap or sign or direction or zero or overflow or carry flag, these are the flag which indicates a status of the particular flag or particular condition. Okay, and control flag is nothing but interrupt, auxiliary and parity. So what are they? We will see. Carry flag is nothing but whenever we do addition, we borrow, okay, or the subtraction, we borrow, we carry one number, that indicates the error condition, which is nothing but carry flag. Parity flag is nothing but whenever we do even and odd program, the parity flag represents zeros and ones. In the auxiliary flag is nothing but whenever we do addition or borrow after subtraction or addition. Okay, the bit position like 3 and 4 of the result, for example BCD addition or subtraction, we need half carry. Okay, that is nothing but auxiliary flag. Zero flag represents the result, which is 0. Sign flag represents the positive and negative, which is the status in 1 and 0. Okay, which is an ALU flag. Trap flag is nothing but it is a control flag. Control flag is what? Control is nothing but trapping on chip debugging feature. Okay, interrupt is nothing but whenever the operation is performed, the interruption is done. Whether it is disable or enable, it is done by INTR pin, which is the flag represents the disable and enable of that particular pin, which is interrupt. Okay, then we have direction flag, which nothing but gives the direction for increment or decrement of the SI and DI index, like okay, data index and source index. Overflow is nothing but the number of signed numbers are added or subtracted. Whether they are added, they are overflow. We have now second phase, which is BIU. BIU is nothing but a 6-byte instruction queue. Okay, queue is we have already seen in DSU what is queue. The segment register is nothing but CS, DS, ES and SS. Okay, we have here IQ, which is instruction queue. We have here 1 2 3 4 5. Okay, 5 instructions over here. In that 4 instructions are nothing but segment register, and last one is the pointer. Okay, and the E represents the sum of block. Okay, now what are these C bus, B bus and A bus? These buses are the channel to transfer the instruction from one end to the other end, from one register to the other queue, from one queue like here, from this instruction queue to the instruction stream byte queue. Okay, so it transfers through these buses. Okay, like in the normal life we use buses to transfer the instruction to transfer the passengers. So here in the 8086 microprocessor we are using to transfer the instructions from that particular bus. Your memory interface is nothing but from where the source of memory is extracted or fetched for the architecture for the instruction. Sorry, the queue. So what is the queue? The queue is nothing but it prefetches 6 bytes of instruction code. Okay, and then it uses for the BIU to run the sequential instruction one by one. Okay, in a proper linear format. Okay, so here it now we are using queue. Queue is nothing but FIFO. FIFO is nothing but first in first out. Okay, first instruction will be entered and it will be executed, and then it will be out immediately as an output of the architecture. Okay, and then it will go to EU for the access of the output end. It might go in the ideal state if there are no buses or there are no intervals in between. Okay, then we have segment register. Segment registers are like 4 registers segments which represent CS, which is code segment, data segment, extra segment, stack segment. Okay, all are 16-bit register. Each of these segment register store 16-bit address of starting address of corresponding segments. So all these segment can store the 16-bit address, 16-bit numbers in the decimal numbers like AX, BX, CX. So these are the segments where we can store the registers in it, like AX, BX, CX, and in that we have 8-bit like AL, BL, right? AH, AL, BH, PL. We can store in this segment. These are nothing but segment register which stores the register. Okay, so overall we have all this 8-bit AH, BH, CH which is stored in AX, BX, CX, DX. These are the register which can be used in the segments like CS, DS, ES, SS. And instruction pointer is nothing but points of instruction which is not used in IMIC. Then we have flags. We have seen the flags. Okay, we will see all these certain points in the program. Okay, which might get in detail for you for the further things. Then we have segmentation memory. Segmentation memory is nothing but these are the segments, okay, which is 64 KB each. Okay, it is organized in a segmented memory. In the CPU of 8086, we have 1 megabyte of memory which is able to store the addresses. So the complete physical available of memory may be divided into these segments, which is overall into 1 MB, when megabyte, which is a physical memory. So whenever the question is asked for 2 marks, explain the segmentation memory of 8086 microprocessor, you have to include that all segments are included or included in the physical memory, and the physical memory is divided into all these 4 segments, which is 64 KB. The physical memory is equals to 1 megabyte of a memory in CPU 8086. So this was a unit number 1. Okay, so this was our unit number 1, which was of which was of 14 marks, as we can see over here. Okay, then we will see one by one practical, like not all practicals, but whichever are basic and which might be asked in exam. I will cover only that much of program over here. So our next video will be on how to install TASM to run our program. Okay, TASM in a computer and how we can run a program for basic like performing addition and subtraction of two numbers like that. That will be our next video of MIC. We have completed unit number 1, so unit number 2 will be started in the other next video. Also, our JPR video is left, which was guessing paper Java programming like of SPPU. We will see one by one question with proper explanation in Marathi so that you can understand. Okay. So yes, if you like today's video, do like, share and subscribe.